Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey.
Hi everyone, we're going to discuss about permutation. So let's see how we're going to relate it to the one that we discussed last time, which is on fundamental principles of counting. Let me start with a question. In the top 5 candidates for the Miss Universe pageant, how many possible outcomes for the first runner-up, second runner-up, and third runner-up are there if the top 5 are Miss Philippines, Miss USA, Miss Australia, Miss Argentina, and Miss Italy? So, if this is the case, what do we know about the problem? First thing we know is that we have the top 5 candidates and we need to fill in 3 positions. The first runner-up, the second runner-up, and the third runner-up. If we are to fill in these 3 positions, the question is how many possible outcomes will we have for this particular scenario? So, applying the concept of what we learned last time, we know that for the first runner-up, we have the top 5 candidates, we have 5 choices for the first runner-up. Since one will already place in the first runner-up, then that means on the second runner-up, we only have 4 choices left. Now, having the second runner-up in place, therefore we have 3 choices left for the third runner-up. That means, in this case, we have 5 times 4 times 3 possible ways that we can come up with this arrangement. So 5 times 4 times 3 would be 60. So that means there are 60 possible outcomes for the first runner-up, second runner-up, and third runner-up in the given situation. Let me give an example. What are the possible outcomes that we can have? For instance, the first can be Miss Philippines, the second can be Miss Argentina, and the third can be Miss USA. If I will have another arrangement, I can have Miss USA as the first, Miss Philippines as the second, and Miss Argentina as the third. If you're going to look at the 2 sets of data, they have the same elements, right? They both have Miss Philippines, Miss Argentina, and Miss USA, but the second one is placed in different order. Does that mean it's 2 different items based on the possible outcomes? The answer would be yes. These 2 are 2 out of the 60 possible outcomes that we can come up with a given situation. So it means that you can actually name 58 more if you want to. So in this case, when we talk about arrangement, where order is important, we are actually dealing with what we call permutation. So what is permutation? Permutation is an ordered arrangement of R objects from a set containing n objects, meaning we're going to arrange n objects in R numbers of position. The total number of R permutation of a set with n elements is denoted by the given formula. So, we are already familiar with factorial notation because we discussed this last meeting. So, from our previous video. So, this time it will not be difficult for us to solve problems involving this. But before that, let me ask you first, do you have your calculator with you? Okay, I will get mine as well. Okay, this is good thing. I have my emulator here that will act partner in discussion in statistics. So if I may ask you, can you please key in 1 factorial in your calculator? In my calculator, in the class quiz, we can actually find it as a yellow function of x raised to negative 1. So how do we key in that value? Do you have your answer already? So we can key in that value as 1, then shift, since it's a yellow function of x raised to negative 1, we click on x raised to negative 1, and the factorial notation is already in place. If we click on equal sign, so 1 factorial is equal to 1. So every time that we simplify 1 factorial, that's equal to 1. How about 0 factorial? So if we have 0, shift, factorial, the value would be 1 also. So we know 2 things. First, that 1 factorial is 1 and 0 factorial is also 1. So we're going to need these 2 concepts in our discussion of permutation later on. Going back to the problem, we say that this problem is actually a problem of arrangement. That means we are discussing about permutation. In the problem, we know that we have 5 people, the top 5 candidates for the Miss Universe. So we have it here. And we know that also from the 5, we are going to arrange it into 3 positions. That's why we actually say that 5 is N and 3 is R, because when we take a look at it, that will be permutation of 5 objects taken 3 at a time. We read this as permutation of N objects taken R at a time. That's why when we have this, we can actually read this as permutation of 5 candidates taken 3 positions at a time. Therefore, applying the formula, we have this is N, remember, this is R. Therefore, we have 5 factorial over quantity 5 minus 3 factorial, which is equal to 5 factorial over 2 factorial. If that's the case, we can simplify it further. Let's do this manually. We have 5 times 4 times 3 times 2 factorial over 2 factorial. We can cancel the 2 factorial. We know that because we were able to discuss it when we discussed factorial, evaluating factorial notation. That would be equal to 5 times 4 times 3, which is equal to 5 times 4 times 3 is equal to 60. So, it's the same answer as what we've had when we use fundamental principles of counting. But since it's fundamental principles of counting that talks about arrangement, then we can actually use the formula for permutation. And this is our answer. So, how do we evaluate permutation? Basically, we apply the formula and we solve the resulting expression. So, let's do that. In this case, it's written in different form. Yes, when we have permutation of N object taken R at a time, this can also be written, if you're going to look at other books, it can also be written in this format, which is how the given are written in the items below. Therefore, if we have 5 permutation of 5 objects taken 5 at a time, we can also write it in this form. And given this idea, we can say that following the formula, N is 5 and R is also 5. That means in this case, N is equal to R. Does that say anything for our solution? Let's see. If we're going to consider this and apply the formula of permutation such that we have N factorial, so we have 5 factorial over N minus R, quantity 5 minus 5 factorial, we have in the numerator 5 factorial over 0 factorial. We already know that 0 factorial is 1, so we have 5 factorial over 1, which leave us with 5 factorial. And we know that 5 factorial is 5 times 4 times 3 times 2 times 1, which will give us a value of 120. Okay. So that means when you evaluate permutation of 5 objects taken 5 at the time, the answer is 120. But let's take a closer look at this scenario. Since N is equal to R, definitely, if N is equal to R, the denominator will always be 0 factorial. That will always give us a denominator of 1, leaving us the numerator to solve, correct? So, if that's the case, we can actually say that when we have N, when N and R are equal, we can simply get N factorial when N is equal to R. So, let's have another example. So, if I ask you to find the permutation of 3 objects taken 3 at a time, your answer would be 3 factorial. And 3 factorial is 3 times 2 times 1, that will give us 6. So, there are 6 permutation. Now, this will only happen, or this will only be the case if N is equal to R. But how about letter B? In letter B, we follow the formula. So, the permutation of 7 objects taken 3 at a time is equal to N factorial, which is 7 factorial over the quantity of 7 minus 3 factorial. That will leave us 7 factorial over 4 factorial, We can simplify that as 7 times 6 times 5 times 4 factorial over 4 factorial. We can cancel 4 factorial. That will leave us with 7 times 6 times 5, which is equal to 7 times 6 times 5, and the result is 210. So, there are 210 ways to arrange 7 objects taken 3 at a time. Now, how about the next problem? If we're going to look at the next problem, it seems that we have 2 permutations. So, what are we going to do? Let's take it separately. So, if we are going to do that, that means we need to get the permutation of 8 objects taken 2 at a time and the permutation of 4 objects taken 3 at a time. So, we have 8 factorial over quantity 8 minus 2 factorial. We're going to add that on the second permutation, which is 4 factorial over quantity 4 minus 3 factorial. On the first side, we have 8 factorial over 6 factorial plus 4 factorial over 1 factorial. We know that 1 factorial is 1, so for the other side, we just have 4 factorial. For the first side, we can actually do it as 8 times 7 times 6 factorial over 6 factorial. We can cancel the common factor, 6 factorial, and we're left with 8 times 7, which is 56, plus 4 factorial, which is 4 times 3 times 2 times 1, which will give us 24. 56 plus 24, we have 80. Okay, so that means the answer for the given expression is 80. I hope you know already how to evaluate permutation. This time, let's apply it to problems. How many arrangements are there if 9 students will be arranged in line? Definitely, if we're going to arrange 9 students in line, there will be 9 places to fill. Therefore, we can say that N is 9 because there are 9 students, as well as R is also 9 because the 9th student will fill all the 9 places for them to be arranged in line. Therefore, we can simply say that the permutation of 9 students taken 9 at a time is equal simply to 9 factorial. And 9 factorial is of what value? We key in 9, then shift, and then the factorial. The answer would be 362,880. Wow, there's a lot of possible arrangement, right? Do you agree? Exactly. Now, given this scenario, let's have another example. So this time, let's have another example. If there are 35 students in class and 5 officers will be elected with the following positions: President, Vice President, Treasurer, Secretary, and PRO, how many possible results of election are there? So if we're going to look at it, there are 35 students to be positioned to 5 positions for the officership. Therefore, in this case, N is equal to 35 and R is equal to 5 since there are 5 positions. If we are going to solve this, this will be a permutation of 35 students taken 5 at a time, which is equal to 35 factorial over quantity 35 minus 5 factorial. That will lead us to 35 times 34 times 33 times 32 times 31 times 30 factorial over 30 factorial. We can cancel that one, but let me use my calculator to multiply all these values. 35 times 34 times 33 times 32 times 31. And the result is 38,955,840 ways that we can come up with the position of President, Vice President, Treasurer, Secretary, and PRO in your class. Wow, that's a lot. Imagine if there will be more than 35 students in your class, then there would be higher number of ways that we can form out of the students in your class. So basically, if it's election, Do not be in a hurry because having this number of items to choose from or to identify an outcome with is really no joke.
Now let's talk about another kind of permutation, what we call repeated permutation. The number of distinguishable permutation of n elements taken n at a time with n sub 1 elements alike, n sub 2 of another kind alike, until n sub k of a kth kind alike. To answer the question, how many distinct permutation can be formed from the letters of the word icicle, we have the n factorial. Since there are 6 letters here, then we have 6 factorial over the letters that repeat. The letter that repeats are I, which repeated twice, so we have 2 factorial, and we also have C that repeats twice, so we have 2 factorial. In this case, if we're going to consider expanding the given, we have to choose, since there are 2 factorial notations in the denominator, then only one should be in factorial notation. So we have 6 times 5 times 4 times 3 times 2 factorial over, the first is a 2 factorial, but the other 2 factorial must be expanded as factors. Why? Because there is only one chance that we can cancel 2 factorial divided by 2 factorial. Remember, any non-zero number divided by itself is 1. So in that case, we can consider 2 and the other values in the numerator as its factors. So we can cancel the common factor, which is 2 and 4. 4 can be 2. Can we cancel 6 as well? Yes, if you want to not cancel 4, but rather 6, that can be. So we have 1 and 1 in the denominator. So that would be 6 times 5 times 2 times 3. The answer is 180 as our answer. So there are 180 distinct permutations that can be formed from all the letter of the word icicle. Okay, let's have another example. Let's consider the word Philippines. In the word Philippines, how many letters do we have? Exactly, we have 11. So we have 11 factorial in the numerator. In the denominator, let's identify letters that repeat. P repeated 3 times. So we have 3 factorial. I repeated 3 times as well. So we also have 3 factorial. Other than that, nothing repeats anymore. So we have to express 11 factorial as 3 factorial. So we have 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3 factorial over 3 factorial. On which the other 3 factorial we have to expand as 3 times 2 times 1. We can cancel 3 factorial. We can cancel 3 and 2 as 6. Because 3 times 2 is 6. So this becomes 1. So we're left with 11 times 10 times 9 times 8 times 7 times 1. So we just have times 5 and times 4. Anyway, when you multiply it with 1, it's the same value. The answer is 1,108,800. Wow, that's a lot of permutation.
So we're done already discussing about permutation. So we discussed about permutation of n object taken r at a time. We also discussed about repeated permutation. And last, we discussed about circular permutation. So in how many ways can 8 floats line up for the Metro Manila Film Festival? What do we know about this problem? We know that we have 8 floats to line up. And these 8 floats will be lined up. Will fill up 8 positions as well because all the floats will be lined up. That means the n is 8 and r is 8. This is permutation of 8 objects taken 8 at a time. In short, this will just be equal to 8 factorial. And 8 factorial is 8 shift factorial equals 40,320. If you don't have the factorial notation in your calculator, we have to key in 8 times 5, 8 times 7 times 6 times 5 until 1. So anyway, you're going to have the same answer. So next, in how many ways can 4 of 7 different kinds of bushes be planted along a walkway? So what we know is that we will be needing 4 bushes out of the 7 different kinds of bushes that we have that will be planted along a walkway. If that's the case, that means there are 7 bushes, kinds of bushes to choose from. Therefore, n is 7. And since we're going to position it to 4 positions along a walkway, then r would be 4. Therefore, to solve this problem, we need to get the permutation of 7 objects taken 4 at a time, leaving us with 7 factorial over quantity 7 minus 4 factorial, which is 7 factorial over 3 factorial. We can simply key in that value in our calculator, but I opt to have it to expand it so that everyone will understand. 7 factorial is 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. We can cancel the 3 factorial, leaving us with 7 times 6 times 5 times 4. We have 7 times 6 times 5 times 4, and the answer is 840. So there are 840 ways to choose 4 bushes to plant along a walkway out of the 7 different kinds of bushes that we have. So that's it for today. Thank you so much for listening. I hope you had a great time learning about the basic concepts on permutation.
This had been a great learning adventure. So, see you next time on another math venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!